Hello, and welcome back to the UAS Magazine podcast. I'm your host, Danielle Piekarski, and today I am joined by Noel Heiks, VP of Sensing and Data for Censys Technologies. Welcome to the podcast, Noel.
Well, thank you so much, Danielle. I appreciate it.
Yes, thank you for joining us today. Why don't we start by you telling us about yourself and Censys Technologies?
Okay, so thank you very much. I am a long-time serial entrepreneur, sort of since I was 14 years old, very excited about physics and optics and all kinds of sensing and data for my entire career. I started and ran two successful high-tech businesses and exited with those businesses. And then eventually I came around to joining the Censys Technologies story, where they could put my background in computer vision, AI, optoelectronics, all to good use. So that's about me.
Cool. So I recently posted a story about Censys Technologies' retrospectra system and an agreement with a company called Aerospace. Can you tell us about this agreement and how the retrospectra system works?
Yeah, absolutely. We were so excited about the opportunity to leverage government intellectual property. So this was a federally funded research lab that had created a patent that was very exciting to us. So I'll back up a little bit. The way that we have been historically monitoring greenhouse gases or any hazardous gas that you're monitoring from say from above from a UAS, you're actually doing a spectroscopic analysis. So you're actually analyzing the gas with a laser, actually two laser beams, and one of those laser beams is absorbed by the gas that's in question, and say it's methane, a nasty gas that is 28 times more effective at heating our atmosphere, which is not a good thing, than carbon dioxide. So basically, we're firing a laser. One of the laser beams gets absorbed by methane. One of them does not get absorbed by methane, and that's traditionally how we're doing it. But in order to receive that signal, you're having to bounce it off of a surface, and that surface may be the rough grass, it may be some pipe, it may be some other sort of scattering material that makes it so that the detected signal that comes back to you when you shine it from a UAS and then receive it makes it really noisy and very difficult to discern. So it's not a very good signal. So what we found while we were pouring through the literature, and actually we were looking to patent something that was pretty novel, we actually found that a federally funded lab had commercialized this technology where you have a UAS that's sending two laser beams down, and then instead of scattering off of a surface, instead you're in a very tailored way reflecting back from another surface called a retroreflector, hence the name retrospectra. So they had this technology whereby you can mount a retroreflector on another mobile platform, and then take the laser system from the laser spectroscopy system from another platform, and with coordinated and tracking flight, you can monitor any kind of gas in any kind of 3D motion. You can imagine that it's kind of like an airborne CAT scan of the of the environment. So we were very excited about this technology. Of course, we would like to leverage this where we are commercializing this technology for methane, but we are also very quickly and closely monitoring the ability to commercialize for carbon dioxide, as well as some nitrogen components that are pretty bad for our atmosphere as well. So that's kind of the story. Hopefully I explained it well.
Yes, you did. I was telling Noel before we started the podcast, I also work on the Carbon Capture magazine product line, and how this is interesting because there's a bit of a crossover here. So, Noel, how would you say that measuring the concentration of these gases via airborne intelligence is safer and or more efficient than other methods of measuring?
Great. Well, hopefully I've at least talked about how it's a little bit different than traditional, single, without a retroreflector capability. But let's back up and talk about, what's so important about this. I mentioned methane is 28 times more, sadly, more effective at heating the atmosphere than carbon dioxide. So one of the things that is critically important by 2030 and has been sort of an edict by the White House is to reduce our methane emissions into the atmosphere by 2030. One of the main culprits of this is we have 2.5 million orphaned oil wells that are in our country alone. And there are approximately 20 to 30% of those oil wells that are actively venting into our atmosphere. So here we have all of these fugitive gas emissions that are all over our country. And they tend to be in some fairly remote areas and very hard to find. You can't see them. They're covered over by vegetation. They've been abandoned and out in the middle of a farm, out in the middle of farmlands. Mm-hmm. So what we are working to do is to map using our very long-range intelligence capability to map thousands of miles of land in some of these areas, which are, a lot of them are in the Midwest, to find these fugitive emissions and to cap them for better of our environment and the emissions profile. So that's for methane, and that's a very big problem. And it's not only orphaned oil wells that are, causing these problems. 2.5 million, obviously, quite a bit of methane being emitted into our atmosphere. But there's also, typical oil and gas operations that may have, maintenance issues or defective equipment or, a pipeline that has a problem where there's active venting that they don't know about or they need to find. So how this is more efficient at finding those is we have a long-range platform. We have a very precise capability now with finding these methane emissions. With the retrospectra system, we are able to measure less than 10 parts per million in a given gas column of methane, which is very hard to do from other airborne platforms. If you're up on an airplane and if you're looking from a satellite, you just don't get that granular kind of information right, that can pinpoint where fugitive leaks are coming from. These are low levels of emissions that over time create a lot of problems for our atmosphere. So you can imagine that, if you have a UAS system that's safe, and it's efficient, it can go, so the Censys platform can go 80, it has an 80-mile range, which is unheard of in a lot of the UAS community. And of course, with the BV loss waivers, which we'll talk about later, is critically important to this. So compared to other UAV capabilities, compared to satellite capabilities, it's sort of like in this Goldilocks sweet spot where we can get up close and personal at, say, a few hundred meters or even 100 meters, where we can go and really pinpoint where problem areas are. And we can, with our artificial intelligence and machine learning, we can have the edge processor or the processor on board the aircraft really determine where the problem areas are, so that we don't have to have a lot of people poring over data and taking a lot of time to deal with it. So another thing too about this is I mentioned, and I'm now going to flip it over to yet another market area, and that is we have an issue with carbon sinks, and this is something that you're very interested in, Danielle, the carbon capture picture.
Yes.
It is very difficult to verify carbon credits. So if you plant, say, a given forest over a grassland or over corn, you really don't know what the carbon footprint of that crop or forest or whatever it is that you're planting. You don't know what that. There's a calculation that I planted this many trees and hopefully this many don't die. And then, hey, please issue me a carbon credit for that. It's a little bit of the Wild West with a lack of data. There are some satellite companies, and I can't remember the names of them now, but there are some satellite companies that are doing some good work with large croplands and specific kinds of plants that are being planted, like soybeans, for instance, and calculating from the sky from a satellite via hyperspectral imaging. Which is similar to similar to something that you could do on a UAV, but they're not really, and so they're basically determining what the plant is uptaking by the color of its leaves, for instance. Okay, and I very much simplified the problem. I don't mean to demean all the amazing work that they're doing. But again, it's the same sort of problem when you're doing it from a satellite, or even obviously when you're doing the calculations, right? Just based on how many trees you planted. The data is not granular. You're not really determining how much carbon dioxide is moving through the atmosphere. You don't know how much is really being uptaken. It's a lot of calculation and not a lot of data acquisition. You get what I'm saying? Yes. So what we will do with our retrospector system is fly over and actually monitor carbon dioxide flux. And that is something that we can do with this system. Again, it's not as simple as looking for, although it's not simple anyway, it's not as simple as looking for spiky, a few methane leaks in various areas, right? That's going to light up like a Christmas tree. In this case, when you're monitoring carbon dioxide flux, you're actually going to be going through, again, maybe hundreds to thousands of miles over periods of time, where you're going to be flying through and doing your CAT scans, okay, of the carbon dioxide, and monitoring the direction of flow. So is the carbon dioxide going out of the ground, or is it being emitted, or is it being sunk into the vegetation? So these are some things that we're excited about being able to do, where we have partners who are, the multi-billion-dollar agriculture companies, vegetation management companies. We are working together with those companies very, very closely to really create a roadmap whereby we can achieve a true data storehouse that isn't just monitoring little points or looking from the sky and making estimates of what acres and acres of land are able to capture. So I know that's a very long-winded answer to your question. But, and if that inspires other questions from you, Danielle, I'd be happy to hear them.
Yeah, that's very exciting to hear about. How do you see this technology being used by companies who want to reduce their carbon footprint, going beyond just safety and mitigating issues?
Yeah, so obviously, if an oil and gas company has under its purview oil wells that perhaps are defunct, obviously we are those we are those people who are going out and looking for those fugitive emissions and helping them cap them. We are working together with state governments who have been given. So again, I'm not talking about companies, but state governments have a mandate, and they have close to $1 billion. I believe has been actually it might be more than $1 billion. It might be $2 or $3 billion that has been given to various states to deal with the orphaned oil well problem. So we're helping them, but obviously the oil and gas companies, it's not just safety, it is emissions. There are mandates to reduce our methane emissions by 2030 by some 30%. And that is not an easy thing to do. So we're helping them with that. And then in the reduction of emissions calculation, companies are doing things like reducing their emissions. So some of their emissions they can't stop. They have to happen to some degree while they wean themselves off fossil fuels, for instance. And so again, they might be doing certain things like buying carbon credits. In other words, purchasing the ability to make something happen on the carbon capture side, which in many cases is the planting of vegetation, and that can be crop. They can invest in farmland, they can invest in forest land, etc. But the actual quantification of how much credit is real and it's delivering a reasonable return on that investment to our government, to our planet, that is where we hope to be sort of a rating agency, if you will, of determining what carbon sinks are really truly doing for our atmosphere. So what we're hoping to do is work together with the standards agencies and ensuring that the data is true for the carbon credit world. And and in doing that, we intend to reduce methane emissions. We intend to reduce carbon dioxide emissions. And, there are a lot of fertilizer that we haven't even touched on this. I could talk about agriculture as well. And again, I'm not a farmer or an agriculturist, although my husband is a third generation cattle farmer. He's a rancher. But I have a lot of understanding of additional things that could help or harm the atmosphere from an agricultural standpoint. So we, that's another thing. I talked about oil and gas. We're also talking to many of the very largest agriculture companies or agriculture focused companies, and really trying to help them with a lot of the work that they're doing now. It has to do a lot with data and intelligence of reduction of fertilizers, increased additives maybe for feed for cattle to reduce methane emissions. There are a slew of initiatives that are going on in the agriculture field to increase the ability for carbon capture and reduce the amount of greenhouse gas emissions. In fact, I'll give you another point, and I'm sorry I'm rambling on because there's so many opportunities for this, but one of the largest methane emitters in the world is actually from agriculture. Not a lot of people know this, but it comes from rice paddies. So there is a huge amount of methane actually emitted in rice paddies. And we're not necessarily one of the largest rice producers in the world, but we do produce rice in Arkansas and areas kind of around there. So there are companies that are focused on reducing methane emissions by controlled water involvement in the rice paddy, and also increasing additives to reduce methane emissions there. But in order to actually monitor what's going on and help the environment, somebody needs to be flying over those fields and measuring the impact of those changes. So I've rattled off, lots of different applications for the technology for a variety of different companies. But, I will say also, since people will be listening to this podcast, we are seeking partners that are looking for a way to determine how much a given experiment, technology, et cetera, is reducing carbon emissions or increasing carbon emissions in the atmosphere. We would like to partner with those companies that are seeking that data. So although I've mentioned many applications, I'm sure I'm not thinking of all of them. So come at us, corporate America. We'd love to help you out.
Well, thank you for that answer. That was so interesting. Such a dynamic technology with so much opportunity.
Thank you.
Yeah.
Thank you.
But to step away from that and look at Censys more as a whole, Censys does specialize in beyond visual line of sight aircraft systems and boasts a 100% success rate in receiving waivers. What has that process looked like in the past? And do you have any advice or tips on the matter?
Yeah, I think that's really a Censys. Censys has been, it's a very, very young company, and they've done a very good job over the past several years working hand in hand with the FAA. Because at heart they are aircraft aficionados. You know, they're all about. I am not an aircraft aficionado. I'm a payload girl. You know, so I'm like, okay, just put it on any platform and I'll be excited. So, but they've worked hand in hand with the FAA, and they are continuing to do that with the evolution of beyond visual line of sight, where I think in the coming years there will be some very exciting there will be some exciting new things that come out of Censys that also come out of the FAA that will reduce the requirements of receiving waivers, but of course enhancing by many factors the redundancy, the safety aspects of beyond visual line of sight. So I think, you know, my tips and really my understanding of the beyond visual line of sight story is that it's critically important for long line critical infrastructure, which has been the Censys technology wheelhouse. So we specialize in looking over miles upon miles, as I mentioned, thousands of miles in some cases, of power lines and energy infrastructure, oil and gas pipelines, water pipelines and waterways, as well as rail and railways, which have all kinds of other issues, vegetation, agriculture, things that have very long line infrastructure. And just starting from that history, that is where Censys they had the problem to begin with out of the gate. And so they've had to focus on what is the best way that they could hold the hand of the FAA, hold the hand of the customer, and make sure everybody's shaking hands in the end. And they have a solution where you can go over a long line border fence and not have any issues. You can go over a long line oil and gas pipeline and not have any issues, and have a coordinated result for the customer and for the FAA as well. The other thing too is we have these mobile command centers, our Centurion mobile command centers, which are also Intel centers. And what it is it's a truck-based or trailer-based system that can go along with the 80-mile range Centero, follow along and create a home base for recharging and for additional fleet. So say you have 2 or more aircraft and one is charging on the truck and the other is in the air, you can go meet that one Centero that was flying and then start to fly the other and capture all of the information and data and do edge processing right at the mobile command center. So it's pretty exciting, the ability to do beyond visual line of sight. But the tips that I would say are, if somebody's looking at doing beyond visual line of sight, talk to a company like Censys Technologies that's been there, done that, and that has that as their purview. We are not a company that just sits in one place. We're, and investigates something very thoroughly from 400 feet up. We're a company that's looking at miles upon miles of infrastructure. When you have a problem like that, come to a company that understands that very multifaceted problem.
Well said. Well, we
Thank
are
you.
coming to the end of our time here. Noel, did you have anything else that you would like to add?
No, I really appreciate the opportunity. Again, as I said earlier, we are seeking partners throughout corporate America as well as government. We have customers that are government customers as well as commercial customers. We're very excited to come out and demo with companies as well. We do Centero tours every year. We do multiple ones of them where we cover the entire country. So if you're interested in talking to us, I'm sure my contact information will be there somewhere in this podcast. Please contact me or anyone at Censys Technologies. We're very excited to talk to you.
Thank you. Again, we are joined by Noel Heiks, VP of Sensing and Data for Censys Technologies. Thank you again, Noel. And thank you to our listeners for tuning in. If you or your company is interested in recording a podcast, please contact UAS Magazine. We hope that you enjoyed this episode, and we look forward to next time. Until then.